Okay, so thank you everyone for coming to this talk. So my name is Joseph. I'm leading EKI blockchain security, and also I am an assistant professor at the Czech Technical University in Prague. And today I will speak about some AI stuff, as pretty much everyone on this panel. Because times have changed. This month, April 26, that was the Armageddon. It was the second worst month in DeFi losses ever. If we don't count the Bybit hack, it would be the first month, the worst month. But the problem is this was not a single hack. This was like a constant month that every day a protocol was hacked, and I would say it was kind of like failure of the all security in DeFi. This should not have happened. What was the cause? Of course, probably AI. Black hats get familiar with AI sooner than the white hats. And if we look at some numbers, we can use EVM Bench. If we ask the LM models to identify possible attack vectors, the overall average of detection is something like 45%. But if we know that there is a vulnerability and ask AI to write an exploit for that, the success ratio is about 72%, which means it's easier to exploit issues than to discover them. So it's a huge advantage for the black hats. And what the rest of the industry that still is here has to do is, of course, to catch up. And I'm happy that all the previous speakers at this panel were addressing this topic. So basically, security guys now know that they have to work with AI. How does the security landscape look right now? I would say there are about 4 tiers of tools. So the first level is the plain models. It's basically back in the day called script kiddies, who just take ChatGPT and write, please hack this protocol. The sad news is it's quite good. Then the upgrade to this is provide some additional context using, for example, skills. So you can have LM with skills. Here, one of the industry, I would say, standard skills are from Trail of Bits. One of the mostly visible on Twitter skills are from Peshov. They are open source, everyone can use it. You can upgrade your LM using these skills. Then there's like the old school batch. These are the tools that were there even before. Deterministic scanners, because the others LMs are non-deterministic. So we still have static analysis, we still have fuzzing. And then there is a, I would say, new category of tools that's now reacting on the situation, and it's a multi-tool, multi-agent tools. And that's probably where the defense is. And to name some of the tools, Nethermind has their audit agent. We at EKI, we have our Wake Arena. The question is, how does it work and how can we know what works? It's not that easy, that's the problem. But first, let's look like what are the obstacles of AI doing the perfect auditor's job. Why AI didn't take over all the auditor's job yet. The first thing is the context size. If we have some frontier models with 200K or even 1 million tokens context, still like a bigger DeFi protocol, which has a lot of dependencies, doesn't fit into the context. Which means the AI doesn't see it all. For this, of course, there are approaches how to address that. One is the native orchestrator, which basically is, for example, cloud code. Cloud code, if you type there, I don't know, do security scan of this repository, internally is slicing that into the context, running multiple agents in parallel, and this is the deterministic, or this is the native orchestration framework. But still, it's kind of random. You don't know what will it do. which we can see on the numbers, that sometimes it works better, sometimes it works worse. So the other approach is having something deterministic. We call it deterministic orchestrator, which is basically like old school program that is running the prompts, but the program is driving it every time the same way. So we don't depend on the built-in reasoning frameworks from the model providers. The second problem is that we still don't fit into the context, and finding bugs in DeFi is about a lot of integrations. So for example, we have cross-chain calls, and in a typical cross-chain call, the context of the two different chains is also pretty big. And the plain LLM model or the plain LLM model with the default orchestrator doesn't discover these like distant relationships. For this, we need some extra tools, and the tools can be the tools that we already had, which is the static analysis. So if the static analysis, using some graph theory or something like this, provides additional, let's say, hints to the LLMs, it works much better. The third problem, and probably the biggest one, is triage, which is basically to find out if the finding is valid or is false positive. Because on average, about 80% what comes from the AI, if you type, find me bugs, make no mistakes, 80% of that is false positive, is a mistake, And that's the reason why all the bug bounty platforms are just like flooded with security reports. Immunify is banning about 20% of accounts because they are producing AI slop garbage, and who has to read it? So that's a real problem that right now probably there are true positives among these findings, but there is too much that no one wants to read it, So this is the hardest problem to solve. I would divide the systems that are solving this into 3 different categories. So the first one is the plain model. It's find all bugs, make no mistakes. It's this. If we upgrade it with skills, we have the agentic reasoning loop, the same as the base model. But up to that, we add the skill file, which could be some kind of like methodology, hints, specifics about the protocol. And the third layer, it's what we do in Wake Arena, or probably others are doing it as well, is that we add to these 2 things also some information that is deterministic, which comes from MCP servers. And what we do, we provide static analysis results, we provide the call graph, we provide data dependency graph. And also what we have, we are not relying on cloud code as a reasoning framework. We have our own in-house deterministic orchestrator that is built specifically for security. So does it work? We need to see some data, but it's not that easy because, of course, when we want to benchmark multiple auditing tools, they have to be benchmarking on the same data set, and there is no data set like for security, or some academics try to define some data sets, but of course the problem is when you create a data set, you can fine-tune on the data set, which means it doesn't show then in the future that it will work. So everyone is benchmarking against something else, which means if one benchmark tells, we discovered 98% of the issues, it doesn't tell it's comparable with 50% from the other benchmark. So it's kind of mess, of course. What exists on the market as a benchmark data set is EVM Bench from OpenAI /Paradigm, but we didn't like it much because there is a lot of old contracts in that. So it's basically like solving something that was already solved. Then another benchmark was presented by Anthropic. We also didn't find it like very Web3 native. There's some academic stuff. And the last benchmark is from Zelig, which is basically from Code4Arena. And it's a data set of 94 vulnerabilities that were discovered across 14 real protocols, and it's quite recent. So that's the reason why we like this data set, and we have built our measurements on this data set. Of course, the data set is public, which means everyone can replicate the measurements. It's the core of the idea of having a data set. And how does it look? So it's a public, fixed, real bounties discovered by humans. We know that the humans across all the platforms that this benchmark or this data set was present discovered there 94 critical or high severity issues. So this is the recall, 100% is 94. It's built on 14 real protocols, and important thing during the measurement is that we have to disable our searches because the models are clever. And when we wrote to GPT, find all bugs, make no mistakes, it was cheating. It was trying to find audit reports, online. So we had to cut off the internet so they are not cheating. And so this is core of our benchmark. What we tested, we took 6 systems. Every time when a new model is released, we test it internally. So we tested from GPT-4. Now this data I will present is GPT 5.2, and GPT 5.5. Important is to have the parameter extra high reasoning, which means we are trying to get the best out of the model. We also, of course, benchmarked Opus 4.7 on max reasoning. Then for reference, we took the Peshov skills, and we were running that on the strongest model, which is Opus 4.7 with max reasoning. And then we took 2 versions of our Wake Arena. One is older, the second is newer, we call it upgraded. And this is what we tested. So how does it look? This is the result. So the data set, which had 94 findings. In this data set, basically, with Wake Arena, we are able to get to 66 findings out of 94. So we have a recall. Recall is the numbers of issues discovered out of all issues. So we have recall 70%. The older version had something like 67. Then the best performing LLM model in the plain mode was Opus 4.7 with max reasoning. It discovered 48 issues out of the 94. With Peshov skills, it discovered 1 issue more, which I think is nice, but I was surprised that it's not that much. And then is data from Zelig from their scanner. To be honest, this is their data on this data set, which is from the end of the last year. They didn't update the data, so probably they are now somewhere else, but this is where they were at the end of the year. And you can see that GPT 5.2 is much worse. To GPT 5.5, I can tell that it also depends on the task. For example, Opus is very bad at Uniswap mathematics. GPT 5.5 is very good at it. So this is also some part of our know-how. What we do is that we are prompting different models for different tasks. That's why we have the better results. If you look just at the winners, to recap, so the best performing plain model is about 50% recall. We are able to get about 20% on top of that. Of course, the question is, when Mythos arrives, nobody knows how will it perform. But of course, what we are trying as auditors to do is always to max out most possible outcomes from the plain models. And if we will be able to keep the advantage of about 20% on the most up-to-date model, I think this is fine. There is also another view on that, which is cost. The prompt on the best performing plain model costs, on average, $2 per 1 vulnerability discovered. So basically, if some of you are here, white hacks who are on Code Arena, so this is quite of bad news for you that for high or critical, the price now is $2. If we try to get more of this, the efficiency goes down. So of course, with our frameworks and reasonings, we are somewhere around $5 per vulnerability. And if you looked at the Peshov skills, basically, we are at $11. So for like 1 more finding out of 97 findings, we paid like triple the price, 4 times more the price. So it seems like the reasoning frameworks of the models is so good that providing it with like general skills that are not tailor-made for protocol makes no sense. Just the skills. There's also a view on the single projects that are inside the dataset. So you can see basically this is Wake Arena. The second thing is the best performing model. It's quite consistent, so there's no like the data were gained across all the projects. It's not like that we gained the findings in one project. What about the false positives? That's an important question. The answer is we don't know. The problem of all these data sets or all the results everyone is publishing with the AI security tools is that they don't publish the false positive rate. So I cannot compare to it. I don't know what is their false positive rate. What we can tell about our system, we are trying to tune it that way that the false positive rate is below 50%. We could have more findings, like higher recall, but at the cost of more false positives. And for us, the like hard stop is at 50%, which means once we hit more than 50% false positives, we are able to sacrifice some of the true positive findings, because then no one would probably read the report or trash the issues. The question is, as I said, the data set is quite recent, but of course the newest versions of the models could have been trained on the data set, which of course will show better results, but it will not tell that in the future findings it will perform the same way, you know. So we did one more small benchmark, which we don't publish, or didn't publish, will not publish. And we just looked at some audits that basically are not public. So we looked at 5 audits that we performed in ECI within the last quarter of 25. And these audits didn't have published reports. So none of the models could have learned on them. And we just took these audits. They were performed by the best security engineers of our team. And we compared that with the models. So try to guess. It's kind of brutal. The humans within ECI, which I think is kind of top-tier auditing company, discovered 31 findings, which is the baseline. GPT 5.2 discovered 29 findings. Our Wake Arena discovered 35 findings. So basically, the tool outperformed humans here. And this, of course, means that something is wrong, or at least for me, there was a wake-up call, that the current security is broken. We cannot continue as we were working before. So from now on, basically, the auditors, they need to be creating their tools, because auditor without a tool is outperformed by AI. That's sad, but it's how it works. The good news is that if the auditors create something meaningful, it's still possible to outperform the base models, which is nice. So basically now the skill is in this. But it's not only that bad. If we look at the findings, there are still some findings that the AI is struggling to discover. And mainly these are logic issues. So if I was an auditor right now, I would be focusing on finding these, because these are the ones that AI misses. And it's economic exploits, it's protocol invariance. For example, when we ask AI to create invariance for a protocol, it usually creates garbage. So the AI, it doesn't have the idea, you know, what could go wrong. So in this, the human thinking is still much better to bring some idea. So we are now focusing on finding invariants, not on testing them. And of course, AI still sucks in the very complicated cross-protocol bugs. And as we can see now during the hack season, the governments, admins, and stuff like in the infrastructure outside the contracts, it's still something the AI is missing. And that's something that we know that we have to include in our audit methodology to basically look around, not just look at the contracts. And yeah, so what are the takeaways? Security needs to be built on multiple layers, as always. And now the layers look like there should be some cheap scan for the CI/CD. There should be some like very robust, the best AI tool possible, for the pre-deployment checks. There still should be the humans, because even the best AI catches 70% of the issues, at least in the data set, not in our internal benchmark. So there is still space for human work. And then in the end, it's of course still the bug bounties. So yeah, this is the best we can do. Build a security from multiple layers. And we have to focus on building better AI systems than the hackers do. And what is the system? So of course, what I would like to everyone in the industry who's building some tool, please do benchmarks on open data sets so we can compare, get inspired by each other to see which basically systems are good marketing and which AI auditors are good tools. And yeah, that's pretty much all. So thank you for the attention. We have still 3 minutes, so maybe.
Thank you very much, Josef. Very interesting. Do we have questions from the audience? Yeah, several. Maybe I'll just give you a microphone.
Did you try like a hill climb approach up or are you experimenting with that? Like something like order search where the model makes up the hypothesis, tries a lot of parallel experiments. And
so there's like echo. I don't hear
hill
much.
Climb up, like auto research by Karpathy, something like that approach for the audits.
So what is our approach for the audits?
Yeah, I mean, are you trying something on those lines as well?
Like this is now part of our audit methodology. So basically, in our manual audit reviews, we know that this AI tooling is a necessary step there. So that's the takeaway we made in late 25, that this needs to be part of every auditor's methodology.
There's another question here.
Hello there.
Hi there.
Thank you for the talk. You've mentioned that this April was a terrible month because of the hacks, and you've connected it to AI. But what's your take on the fact that most of the hacks that happened in April were actually not smart contracts, bugs, or whatever that was eventually discovered by AI, but more of a configuration flows and off-chain issues? So what's your take on that? And do you have any ideas on how AI and auditors can also help with that rather than just the smart contracts code?
Yeah, thank you. It's of course like my assumption that this was thanks to AI, because like before Opus 4.7 there was no bloodbath like this, in DeFi, but it's a speculation. But as you said exactly, it shows some kind of like majority that the smart contracts are now not the weakest security part in the systems. The weakest part is elsewhere, which of course means that auditors, AI tools need to look also elsewhere. So that's the reason why bridge configurations, Oracle configurations, everything like this needs to be part of the audit, not just the smart contracts.
All right. Thank you very much, Josef.
Thank you.
Thanks for being here.
You too.
The next talk will be the first talk of our second track, Sustainability and Speculative Futures.